Good afternoon and good evening. Thank you very much for joining us today with this jointly hosted RemPlex and EnviroNet seminar. My name is Nick Chafogu. I'm a laboratory fellow at the Pacific Northwest National Laboratory and one of the deputy directors of RemPlex, that is the PNNL Center for the Remediation of the Complex Sites. I'm joining today by two distinguished colleagues, Becca Iverson from the Pacific Northwest National Laboratory and Horst Monken-Fernandez from IAEA. Both of them, they will be facilitating the seminar today. But before we start, I would like to recognize and acknowledge the help of Karen Smith, Kelly McIntosh, and Melissa Perdue for putting together and organizing all this seminar and the other seminars of RemPlex. Before I start, I would like to announce that we have started the work to put together the second summit of the RemPlex. We are very excited about it. The summit will happen in the dates of November 4th and 6th here at PNNL, and will be a variety of topics that we would like to discuss. Will be a hybrid and in person. We would love to have people in person here visiting us in Richland, but there will be a hybrid option as well. And then we will have in-depth case studies, topic-specific technical sessions. We will have a general poster session. And of course, the historic and famous Hanford tour will be part of our festivities here and will be optional training workshop as well. We would love to see you all here in November 4th through 6th, 2025. And right now, let's switch back to the seminar. This seminar is brought to you by RemPlex, and again, is jointly hosted by EnviroNet, that is the IAEA Network of Environmental Management and Remediation. The topic of the seminar today is sustainable remediation and decommissioning in practice. And we do have an outstanding panel of panelists today that agreed to actually be part of this seminar of ours. Let me go over some logistics before I turn it over to Becca and Horst. This seminar is being recorded and will be available on the RemPlex and Environment websites following this seminar, along with a copy of all slides of the presentations that we will be presenting today. We would like to take a few questions at the end of each presentation, but we'll reserve time at the end of the seminar for open discussion. I would like to ask everyone to please mute your microphone during the presentations. And right now, I'm going to turn the floor to Becca and Horst to start the seminar. Thank you.
Thank you, Nick. Really appreciate that introduction. We won't waste a ton more time. We want to get right into these really good talks. As Nick said, we're really excited for our speakers today. So as Nick said, our topic is sustainable remediation and decommissioning in practice. So as an overview scope, we're going to explore how to incorporate sustainable outcomes into the planning phases of remediation and decommissioning projects, how these outcomes are measured and vary across the breadth of activities, and specific approaches and initiatives that can provide confidence in reaching sustainable goals. I'm going to hand this over to Horst now so that he can introduce our first speaker, if Horst has audio and microphone. We were having a little
can you hear me, Becca?
Yes, thank you, Horst.
So I'm making a little bit of magic here. So thank you all. Welcome everyone for this webinar. We are pleased that I don't know where to look at my computer or to my mobile phone. We are pleased you could join us today. My name is Horst Monken-Fernandez, and I'm the IAEA Scientific Secretary of EnviroNet, and working in collaboration with PNNL to host this seminar. So we have got an excellent panel of speakers, really very nice professionals lined up for you today. And I'll start by introducing Paul Bardos, who will be our introductory speaker. So Paul Bardus is the Managing Director of R3 Environmental Technology, a small environmental consultancy established in 1997. Paul's technical expertise relates to reuse of land and resources, circular economies, contaminated sites, brownfields remediation, and sustainable and risk-based land management. Paul contributed to the establishment of several contaminated land management networks, including NICOL, the network for industrially coordinated sustainable land management in Europe, and UK Contaminated Land Information Charity, CLARE. In addition, Paul is co-chair of the Sustainable Remediation Forum UK, also known as SURF UK. So, Paul, you have the floor, please.
Thank you very much for a very kind introduction. And I'm going to make a fairly swift overview of sustainable and risk-based land management. Is the presentation showing correctly in full screen? Can somebody let me know?
Yep.
Yes.
Okay, I'm just turning my timer on now, Becca. So you can see here a site in Kosovo, which was a former metal processing area. And around the trees, you can see a deposit. And this whole area, when the wind blows, the contaminated dust blows over the river to that white building at the background there, which is the main hospital in Mitrovica. So this is a very graphic illustration of a source pathway receptor relationship. And that is at the basis of risk-based land management. So I'm sure that I'm teaching a lot of my grandmothers how to suck eggs through this presentation. If so, so be it, but maybe it helps to paint a general picture. So for a risk to be present, at least for conventional contaminated land scenarios, there needs to be a source, something toxic or hazardous, a receptor that might be impacted, and a pathway between them. All three components need to be there for the problem to be apparent. And that also shows us how we can manage the potential harm. That might be treatment at the level of the source, which we call source management. For example, some form of extraction of DNAPLs. It might be treatment at the level of pathway. So, for instance, a permeable reactive barrier. Or it might be an intervention at the level of the receptor. A very common example of that is an institutional control, such as a land use restriction. Very often, we have all three components together. So we might have, say, thermal extraction for a DNAPL source. We might then be relying on some form of enhanced monitored natural attenuation to polish off contaminants that are moving along the pathway. And we might have a temporary prohibition on the groundwater extraction well, for example, as an institutional control until the monitoring tells us that it's safe for us to continue pumping. If we add sustainability into that picture, then as well as mitigating unacceptable risks, we also want to maximize sustainability gains and minimize sustainability losses. Now, this might be across a portfolio of sites, it might be for a single site, or it might even be at the level of specific source pathway receptor linkages within a site. And our goal is to find an optimum remediation solution using a balanced decision-making process that includes different stakeholders to mitigate unacceptable risks while at the same time maximizing overall net benefit. And there are advantages of this. So the risk-based land management component, using risk assessment gives us an objective understanding of likely harm. It gives us this methodological framework and rationale for effective remediation by breaking source pathway linkages. And of course, it allows us to prioritize our resources to the most urgent problems. If we're also including sustainability, then we can optimize the risk management. For example, we can pay better attention to mitigating secondary impacts like fugitive emissions of VOCs. We can look at the wider benefit and greater value to get a better idea of cost effectiveness. It can also be very helpful as a foresight tool to identify and avoid project risks in the future. So, for instance, we have some big gasworks remediation projects stalled in the UK because of stakeholder worries about odors, and this could have been perhaps predicted by a sustainability assessment in the first place. And it gives us an ability to link to targets like the UN SDGs and evidence to support our sustainability claims for reputation and public relations purposes. There's a very wide interest around the world in sustainable remediation. So all of these green countries have some kind of sustainable remediation forum in place or are connected to a network where sustainable remediation is important. There's a book that I've done, which I hope will come out next year. Just flag this for you, which is a clear single narrative about sustainable and risk-based land management for contaminated sites in practice. However, the content on radionuclide sites is very limited, so maybe there's an opportunity there to make a more targeted publication as well if anyone's interested. You'll have my email address or you'll have it from the organizers. Anyone who wants to get in touch with me, very welcome to. Thank you very much. And Becca, I hope I stayed within my 10 minutes.
Smashed it. Perfect. Thank you, Paul. That was a really great introduction, very much teeing up our next speaker. So before we move on, I just want to offer the chance for anyone in the audience to ask any questions. I don't see a question in the chat so far, but feel free to put questions there if so.
Becca, I have a question.
Of course.
If you allow me to Paul. Paul, you touch on the word optimization, and this is a word that is very much in the scope of radiation protection. When we talk about the three principles of radiation protection: justification, optimization, and limitation of the dose. And then we need to define what is the optimal solution, a term that I believe that you also use. So how can you deal with defining what could be an optimal solution, or as you said, a balanced solution, where you put together the economic factors, the social factors, and that brings us to that discussion we have entertained so far. What are the kind of indicator where we can decide how sustainable is sustainable? We used to talk how safety is safe, how sustainable is sustainable. How do you elaborate on that?
So I can elaborate on this on the basis from conventional contamination problems, not radionuclides, but I know this is something you're thinking about, so you can supplement my answer. I think for sustainable and risk-based land management, the preemptive rationale is that you are controlling risks where there might be a potential for harm, and that you can't trade off sustainability against protection. So what you're seeking to do is to find the optimal way of getting the level of protection that you need. And there might be several different means of doing that. So for instance, there might be removal to an off-site disposal. There might be some form of on-site treatment. There might be some form of reuse of materials in a controlled way. For instance, for Fukushima, the government in Japan plans to put material underneath a new road where it will be, in their view, safely contained. How we judge which is optimum, I think, depends on two things. Your understanding of the scope of sustainability, so which environmental, economic, and social factors are crucial for you, and also the opinions of different stakeholders. In my view, it's not a quantitative equation. There are no kilograms of sustainability. What we're trying to do is find a shared opinion between different stakeholders across quite a large number of criteria. And those criteria might be, for instance, to do with impacts on the environment side, to air, soil, water, ecology, use of natural resources and wastes. For economy, there might be obviously the direct balance sheet, but there might be secondary economic effects in the wider local economy. There might be tertiary benefits, for instance, encouraging inward investment. There might be benefits for employment and skills. And we also need to consider the resilience of the different options, particularly in the light of climate change and economic sustainability. And similarly, I'm running out of time, so I won't make a list of social criteria groups, but a group of those. And Surf UK has published its checklist of criteria. That could be a useful place to start, but I think that the criteria are very site specific and problem specific. So at that point, I'm going to pass back to you, Horst.
Thank you. Thank you so much, Paul. There is a question in the chat, but I will leave it for the end of this presentations. So I hand back to Becca. Please go ahead, Becca.
Thank you. That was great. Yes, we'll try to take as many questions as we can at the end. So I'll go ahead and introduce our next speaker, Sarah Bullock. So Sarah is an associate contaminated land and materials management specialist working for Atkins Realis with over 19 years of industry experience. Over her career, she has delivered numerous contaminated land projects on behalf of a diverse cross-section of clients. She has extensive experience in successful delivery of projects with a priority on identifying innovative solutions to contaminated land and material management issues, ensuring that value engineering opportunities are identified and realized. Her current focus is managing the contaminated land and material management delivery on the regeneration of the Teeswork site on behalf of South Tees Development Corporation. So Sarah, if you want to share your screen, please.
Thank you.
Get started.
Can everyone see? Can you see that, Becca?
Yes, looks great.
Brilliant. So thank you for inviting me today to talk about my favourite subject, which is soils and materials. And the question I am posing to everyone is sustainable management of soils and materials an opportunity or a waste of time? And I'm going to explain in my presentation why I think it is an opportunity, and how we should be working more holistically to manage soils. So yeah, just to introduce myself again, Sarah Bullock, an associate director working for Atkins Realis, mainly focused in the UK, but have a background in contaminated land, but have moved into more interests to do with soils and materials. So what I'm going to talk about is a bit about background of soils. What are they? Why should we even care? What is the opportunity? And I'm going to introduce what I think is the way forward, which is a soils and management strategy. And what does that mean and the benefits of that for projects? So to start with, sorry, have I just unshared my screen?
No, we can still see your screen.
Oh, okay. What have I done? Oh, okay. It's come back. Sorry about that. So background. So where are we and where have we got to this situation? So the construction industry has always considered the use of soils and earthwork materials on its own. And what do I mean? That it's different teams and different specialists and different specifications are produced to decide how to manage soils and materials, which means that everyone sits in their silos. No one looks at the kind of overview of what that means to management and its effective way. And they've never been effectively strategized or managed. And it's always, in my experience, been too easy to take material to landfill. It's always the easier option in respect to time and program and technical expertise. And the only thing that really clients think about is cost, and that's been the big driver to keep materials and soils on site as part of any construction remediation. But if we as an industry across the world need to want to accomplish a sustainable construction, demolition, and excavation industry, we need to start thinking about driving net zero and minimizing waste and circular economy. And we can't do that without thinking more holistically around soils and materials reuse. So I kind of did a bit of a deep dive into what are soils and materials, just so that, we know we'll talk about the same thing. And they're referred to in quite a lot of different ways. I've heard the terms of dirt, muck away, soils, materials, earthwork fill, rock, and it's basically, in my opinion, anything that's to do with use of materials below ground. But doing like a quick internet search of what is a soil, the main things that come up are that it's a real substrate principle for life on Earth. It's what gives us life, basically, and without it, we wouldn't be here. It's a reservoir to regulate your water, your gases, and your nutrients. It's that carbon store cycling and having carbon to live. It's created through weathering. It's biologically active, so it's changing all the time. It's physically, chemical, and biological processes impacts. So each piece of soil is different. Each area is different, and it's a mixture of rock, dead plants, animals, and it's a huge habitat for the support of life and organisms. But then on the other side, can become this engineering medium which facilitates buildings and roads and everything to be built. Materials on the other side is more the kind of side of things when it's that, you're looking at it from an engineering point of view. So you've got your soils, your earth, your rock, but we can also bring things in like industrial byproducts, things that have been discarded, I guess, as part of industry, but that will actually become a really good earthwork fill. So why should we care about soils and materials? So as I mentioned, it really drives the ability for the industry to meet our sustainability goals and net zero objectives. We need to preserve soil health and fertility. We need to grow things. We need to live. We need to survive, and it's fundamental for life on Earth. It really contributes to biodiversity and habitat creation. We need to think more about its climate in its respecting towards climate resilience, flooding, for instance, and the impact it has with climate change. Resource efficiency and circular economy. It's a significant waste potential if we don't think about it and plan to its kind of reuse. And then we get into the things of which become a bit more project specific, which is about cost efficiency and program risk if we don't think about how it's going to be done early, and the reputation damage and the commercial liabilities if we don't do it right, if we don't adhere to the kind of legislation within the country we're working in. So what is the opportunity? There's still so much we don't know about soils as an ecosystem, how it works, how we live, but fundamentally we know that we need them for life. We also know that it's a finite resource. So looking at Google again, soils take thousands of years, 1,000 years for 1 centimetre of soil to form. So that says to me, if we don't protect it and we don't use it and we destroy it, then it's going to take another 1,000 years to produce and replace. So that to me means that we should protect. And it's that, its production rate also depends on the geology, relief drainage, all these other factors. So what you get in one area is completely different to another area, and its production rate changes as well. There's a real opportunity to use soils to protect humans and the environment going forward. If we can manage soils in a way that enables us to clean up the soils, it impacts the quality of groundwater and surface water in those areas, and we can really make a difference in respect to contaminated land and the way we live. Waste reduction is a big opportunity as well. So, there is a huge volume of material that's discarded and considered a waste each year. In the UK, recent figures brought out by the government is that 62% of all materials that consider a waste were mineral waste, soils and dredgings. 62%, like that's such a shock to me. And actually, the other headline was it's going in the wrong direction. That's a rise since before COVID as well. So as an industry, we've got a long way to go. And we need to protect for it being an important carbon sink. So, also half of carbon in a forest is actually being stored in the roots, within the organisms, within the soils, and in the organic matter. So actually, this whole ethos of planting trees to act and to recycle carbon, yes, it's definitely needed, but you need to think of your soils as well. And then the last one is like climate impact. So looking at reuse versus disposal and the impact of disposing, it's not just about a waste and using up a landfill space and the future impact a landfill has on an area. It's all around your transport and your air quality and all those things that kind of are your secondary impact of sending trucks loads of material off to be disposed. So what am I suggesting on the projects I work on and I think is a big way forward for the industry going forward? So looking at soils and materials as a strategy. So looking at a holistic approach on projects. So really thinking early doors around what is it that what material have we got? What material can we reuse? And how are we going to manage our soils and materials to avoid that material becoming waste and enable it to be reused, and also keeping its quality in respect to the kind of more agricultural greenfield soils. So what I'm suggesting is looking as part of that strategy at the waste hierarchy and really driving out the kind of use of that material. So to start with, prevent. Do you need to even excavate a material in the first place? Can you design out that material being excavated, especially on agricultural areas? It's very easy on part of big projects to, for instance, put a haul road through an agricultural area. But is that really needed? Can we think of other ways to construct a project? Then looking at reuse, so how can we facilitate material to be reused rather than bringing material in, taking material off site? Then recycling, so things like your demolition materials on sites, your roads, your old buildings, how can you process that to enable that to be used as part of engineering fill? Then treatment, how can you treat your soil to make it useful, prevent its contamination from being placed again, and actually enable it to be used as an earthwork fill. Again, minimizing what material needs to come off site. And then if all that fails, then yes, looking at recovery and disposal as your least preferred options, but really, really kind of refining and reducing the volume at that lower end of what you can do. So the importance of a strategy, and what does it mean? So it's thinking around at early doors, and I actually believe the earlier the better. So off the offset of a project, how materials are going to be managed. So it really that having it at the beginning really helps to drive decisions made by a project team. So it really sets the kind of ethos and the reminder to the project team of what we want to achieve, and drives their decisions going forward. So it enables also early consideration of your source materials and supply chain. Where are you going to get those materials? Is there a good source close by? And therefore, how do you kind of reduce your carbon by transport and things like that? But it kind of brings together other disciplines and their kind of impact on carbon as well and climate change. It also helps to think about what your risk and opportunities are going forward early, and what is the contingency. So, if you identify a material that is quite tricky to reuse, or is contaminated, it allows you to think about innovative solutions to actually treat that material, test it, do some trials. Can you use it? And if those don't work, what is your contingency? How are you going to get other materials? It enables you to be more proactive than reactive. You can also then put into your timescales and program, like, what is it and how are you going to achieve what you need to achieve? If you need to have some regulatory discussions, if you need to get some permits in place, is there time in the program? If not, how would you put time in the program, and how do you kind of account for that risk of things taking longer? You can set up what success looks like. I know a lot of projects now have KPIs. What does that mean? How do you how are you going to show that this has worked? And I think fundamentally it should be a working document. So having it, at the beginning of the project, it might be quite high level. It might just be an overview of this is what we want to achieve. But as you go through the project design, you can refine it. You can, as you get your cut and fill, once you know more, you get your ground investigation data, you know more and more about the materials being used, then you can keep updating it and it becomes even better as you go forward because you have the detail to back it up. And so what does it mean and what is its mean? How will it be successful? Fundamentally, it will mean that all specialists on a project need to work together. There needs to be better collaborative working in respect to soils and materials. Because as I mentioned at the beginning, at the moment, there's a lot of different specialists with a lot of different specifications, such as landscape specifications and earthwork specifications that all need material, but all think about things differently and their wants and needs. So we need to kind of bring everyone together and think of it holistically. But there also needs to be someone driving this in the project team, someone always flying the flag for soils and material and reminding them of its importance. And so I've kind of put a list below of like the kind of specialists, and that is just off my top of my head. So, your carbon sustainability, feeding into your carbon model, and actually, including soils in your carbon model would be great. That's something that I don't always see and something that I'm trying to advocate for. Civil engineers, they need to understand the soils to actually design structures, and same with structural engineers. Then you get your geotechnical engineers who need it for your earthwork specification. Ecologists, there needs to be more thought about biodiversity, enhancing habitat mitigation areas, and how important it is that soil is understood to be able to design these sites and get the best out of them. Drainage engineers feeds into your flooding and the impact that soils have on that. And then landscape architects and the design of your kind of, what soils you need for your planting. And then we're getting back into, what is my background, contaminant land and waste, and the requirements for remediation strategies. So just to conclude, soils are fundamental to life on Earth. They are needed, and we need to better protect them because they're finite and we need them to live. And we don't understand them enough to also think, well, actually, if we don't understand them, how do we protect them? So we just need to protect them and not destroy them in the short term. They are needed to facilitate remediation and construction. Every site needs to manage soils, whatever capacity. We need to drive a sustainable industry. We need to manage and consider and strategize with a plan. If we don't have a plan, we're always going to be reactive and not proactive. It will require significant collaboration between all specialists and project team, but there's a huge opportunity there to be realised. And because of it, I certainly don't believe that managing soils and materials is a waste of time. Thanks, everyone. Just going to stop sharing.
Thank you, Sarah. Really appreciate that. All those kind of facts and the way you presented the importance of what a soil really is and what it means to us and all its the different roles it plays. And especially just that statistic about the amount that ends up in landfills. I mean, like you said, that is really eye-opening. Mm-hmm. So, Nick, I see you have your hand up. Did you have a question that you wanted to ask?
I definitely do. I really appreciate it, Sarah, all the discussion about soils. You probably don't know, but I'm a soil chemist, soil mineralogist by training. So pretty excited about hearing all that stuff. I just wanted to emphasize the role of the soil minerals in determining the fate and transport of different contaminants and especially radionuclides. I just wanted to emphasize that. And of course, I wanted to emphasize the role of soils in the carbon, in the CO2 removal and sequestration. There is a huge pool of inorganic carbon in addition to the pools that actually Sarah mentioned. That is very important. Inorganic carbon in soils, calcium carbonates and other minerals that are very important in terms of carbon sequestration as well. Very well done, Sarah. Appreciated it very much.
That's good. Yeah, it's a huge topic, and the more you look into it, the more interesting it is. And I am not a soil specialist, as in I understand like the intricacies of everything and how soils work, but I'm super passionate about keeping soils on site and how we do that, because I believe if we think about it and plan, then everything else follows.
Thank you.
Forrest, if you have a question. Yep,
oh,
we can hear you.
Yeah, a quick one. Thank you, Sarah, for your presentation. A question to you is, at a policy level, what could you see as a role of the government in establishing policies that can favor circularity? For example, regarding soil materials, what kind of instruments would you see that a government could have in place?
So I don't believe at the moment that we effectively see soils as a resource. I think we see soils as a waste potentially. I mean, especially in the UK, we do. And we need to rethink that narrative. We need to make it harder to take soils and materials off to landfill. I think it's the easy option. I think if we made it not easier to keep material on site because there's things that you need to think about, contaminated. We don't want to place material around a site that's contaminated. We need things in place. But it's actually, if I want to take material off site to landfill, I could do it tomorrow as long as I've got the testing. I can't reuse material tomorrow. So I think if we actually start thinking about promoting its reuse and thinking material as a resource, then I think, I think that would be a big step. And also, like, if we promote having a strategy for soils like we do through other kind of ways of getting permission to do works on site, like we do ecology risk assessments, we do things like that. If we actually start doing soils risk assessments in looking at its material reuse as a requirement and make it needed, then I think then more material will be reused.
Thank you. Thank you.
Thank you, Sarah. Paul also dropped some CLARE resources in the chat for anyone who's interested in reading up a little bit more about soil material reuse and how it can also be used internationally, which is great. I think we are at a great place to transition to our next speaker. So I will pass back over to Horst to introduce them.
Thank you. Thank you, Becca. It's a great pleasure for me to introduce Christina Gilling. Actually, I have the chance to know Christina recently in a seminar, and since then, she has been participating in different events at the IAEA, and she's speaking about nuclear decommissioning in the context of sustainability and circular economy. Christina is a principal consultant at Pfiser's Group, previously Lloyd's Register Energy Division, where she leads business development of services related to nuclear back-end management. She has worked in the nuclear industry for more than 20 years, primarily related to radioactive waste management and decommissioning planning. In addition, she has extensive experience in sustainable development, stakeholder engagement, and communication. As part of her current work, she spearheads development of approaches for integrating sustainability across the whole nuclear facility life cycle, including deriving a conceptual framework for both small modular reactors, the SMRs, and existing reactors in a circular economy. I had a chance to see a lecture of Christina in the recent conference of the IAEA on SMRs. It was a very successful conference, and she really provided very good insights, and I'm pretty sure that she has a lot of things to tell us today. So, Christina, may I give the floor to you?
Indeed. Thank you so much, and very happy to be here. And to build on Sarah's presentation, really, my view is the same, that let's look at the process of decommissioning a nuclear facility as an opportunity and in a holistic way. So I will basically take that same mindset, but apply it to the decommissioning process. So the whole site with facilities and all its part, including the soil, of course, which was really interesting, the previous presentation. So as a starting point of my presentation, I thought let's really take a step back and realize that the current fleet of reactors, be them large nuclear power plants like the 2 units on this figure in southern Sweden, or research reactors or other types of nuclear facilities. The vast majority of the current fleet were really designed and built without considering sustainability or a circular economy, because those terms for many of the reactors, they were not even hadn't really emerged, and let alone were used in the nuclear industry in that way. And most current reactors, they weren't even built taking into account decommissioning. So that, of course, is the standard these days. So one of my main points is, even as the starting point, current reactors and the reactors of the future, like the of course mentioned the small modular reactors that many countries are planning to build. Future reactors will have a much better opportunity and better prerequisites to be circular, because of course you need to design for a circular economy really to tap into things as a resource. But my presentation will primarily focus on the current fleet. So things that are consistent with circularity, like reusing, be it large structures or smaller systems, and repurposing or recycling the materials, it is certainly gaining momentum and becoming more and more common in the area of nuclear decommissioning. But I would say it's very far from the norm. In fact, standards and regulations are really focused on safety. They were not developed for sustainability. So even if it's because it's such a natural thing, right? I mean, it's the whole world is heading in that direction, and certainly nuclear decommissioning as well. But I would say it's a slow process, but heading there. So this begs the question, how do you decommission a nuclear reactor, be it small research reactor, larger facility, nuclear power plant, in a way that is sustainable and circular, since again, they weren't really thought about that when the reactors were designed or built. Well, like I said, there's a tendency, of course, to start thinking about sustainability, even things like, I mean, minimizing water consumption and power consumption and those things. But in my opinion, if we really are to do this in a sustainable way, we need to think of the whole process of decommissioning as a sustainability process. And part of my background is from the Stockholm Resilience Center. So I think by applying resilience thinking really, again, to the whole process, we can untap a better or more positive picture of the decommissioning process, and not thinking about it as end of life, but really the beginning of something new. And resilience thinking, just a very brief background, it applies in sustainable development at that holistic, systematic level. We think of things in nature or coupled social ecologic systems as complex adaptive systems. So this is really any ecosystem, any forest, any lake, or coupled social ecologic systems like a fishing village or a town that relies on the adjacent forests and so on. And if you think about it and take a step back, a nuclear facility, a nuclear site really is a complex adaptive system when you take into account the surrounding infrastructure, the surrounding towns, where the workers live and where you rely on local supply chain and so on. So if we have that mindset, a very different picture emerges when it comes to decommissioning. And a key figure that is used to describe as at the conceptual level complex adaptive is this adaptive cycle. I just wanted to put it out in this presentation because the adaptive cycle describes really any complex adaptive system, where the for loop, the top arrow there is the system as it builds up resources. Again, whether it's a forest or a coral reef or a town, I mean, the organizations we work for, the countries we live in, you can really take any scale of a complex adaptive system. So it started by building up the resources, and into whatever parts of the system. And then at some point in time, it's inevitable to collapse. Forest fire catches fire maybe, or a town has its main industries go away, and therefore it may or may not. It goes to a different into a different type of system. The back loop is when all the resources are let go and become parts of another system. So again, it's easy to think of it with this picture. If you think of a nuclear site as you build it, at some point you shut it down, and all the parts of the system, including workers and other resources, they are let go and become available as parts for future systems, be them on the site or somewhere else. Now, resilience thinking also, if we apply that mindset to the nuclear site, regime shifts are often described as different modes of the system that have different feedback loops. Many of you have likely heard of tipping points. And the tipping point is when the different regimes or the modes of the system can flip and become very different, unrecognizable, really. And in my opinion, it could help us to think and at the kind of conceptual level, and then pull out different ways of looking at the decommissioning process if we apply this mindset. And I actually argue that at the back end, like from operation and onwards, a nuclear site has 3 regimes or 3 modes, described here as these kind of bowls, where each of them have very different prerequisites, very different feedback loops and mechanisms. And of course, the first tipping point is the decision to permanently shut down reactor, where the site will become very different. It might look the same, but it has different feedback loops because you take away the whole purpose of that facility. But in my opinion, if we are to really think of decommissioning and do this in a sustainable way, we need to think beyond decommissioning. Decommissioning in the nuclear, I mean, in most countries, it ends with when it's clean enough, you cleared the site to the point where there's no need for nuclear regulatory control. But if we are to really decommission, in my opinion, it doesn't end with decommissioning. It ends when you have new uses on the site implemented. And if we think of that last bowl, the last regime, it's easier to plan and do it in a sustainable way. That also involves stakeholders, in particular local stakeholders that are the workers, the neighbors, and local suppliers that are very important to bring into the decommissioning process. So this is done as a collaboration, both from the owner, operator's point of view, and to do with the neighbors and the surrounding infrastructure, which again, from a complex adaptive system point of view, it's part of the same. It's the same system. So if you use that mindset and apply it, what comes out is, like Sarah said, it's really look at the part as potential assets and not as something that needs to go away. It just depends on which type of system or where or when you use it. But really, everything at the end of the day can become an asset. Use this holistic, integrated thinking, and not just as a facility that will undergo decommissioning and focusing on what many, or at least historically, have been viewed as legacy and waste. But from a holistic point of view, depending on the context, I will emphasize that it's the answer to a sustainable decommissioning process will not be the same on 2 different sites, because it will depend on where and when and what the prerequisites are, and what that community or the local communities are reliant on. For example, is jobs important? Do you need to replace the energy with something else? What's the economy of the local communities? Are they very reliant? If you're in a larger city, maybe shutting down a nuclear power plant is not such a big deal in terms of the local economy. But if this is further away and it really is the main employer, shutting down a nuclear power plant can have huge negative economic impacts to the local community and ripple effects in the region. So this holistic thinking is really key. I mentioned collaborate with local stakeholders in particular. Of course, there are other stakeholders as well, but I think the locals are often overlooked, and involve them in the decision making, because this is their site. It really is a host of the facility's activities, and also in long term, once the facility has been shut down, whenever and however the facility will decommission, it will definitely be part of that community. So they need to have a say. I mentioned already creating a vision post decommissioning, I think, is really key if the industry and the nuclear decommissioning is to become truly sustainable and not look at things piecemeal, but look at the whole process as a sustainability process. And like I said, create that vision. What are the needs, not only for the local community, but the region, the country, and how can you replace that or even enhance the outputs? Sometimes I refer to ecosystem services, that an approach based on ecosystem services really could be translated and think of what is this plot of land, what is it used for now, and what do we want it for in the future? Maybe it is bringing back to nature and using the area as habitat, or for some other more nature-based services and products, or it is to have it continue to be a built environment where it's an industrial site, but you can still, of course, mix the two types. But create that vision, do it together with the local stakeholders, because that way also there's a much more resilient path when you decide on what those new uses and reuses can be, or at least what they will give you in terms of, or give the society and local community in terms of output. Again, power, jobs, habitat, those kinds of things. With this resilience thinking, what also comes out is try to start implement the new uses and reuses on at least parts of the site as early as possible, just to start building that momentum. We know, I mean, what's currently at least written and most are following is deciding on a decommissioning strategy that's either to decommission as soon as possible, or to defer and let the radioactivity decay down to levels that make it more accessible, and also funds to be able to build up. But what I'm arguing is start, regardless of strategy, try to implement some uses, because it will help drive that process that I shared before, and get you into the final bowl, if you will. Also expect the unexpected. And we know this from in practice. Many facilities have a decommissioning plan that says, we're going to decommission by a certain date, and the waste is going to go to this disposal facility by a certain date. But I would say that more often than not, it doesn't really happen the way. So what I mean by how you could do this in practice is to have some different scenarios. What if, you don't shut down the plant in 10 years, as it says in the current decommissioning plans, but we see the trend towards life extension. So what if it's shut down in 30 years or 40 years? Or sometimes reactors are shut down for maintenance, and something is discovered and it's never restarted. That happens quite a bit, meaning it was already shut down in the past without anyone really knowing. So expect the unexpected is what resilience thinking also teaches us. And of course, minimize the negative environmental, social, and economic impacts as much as possible. And ideally, as we heard before, try to enhance them. So more the traditional approach. So the topic of my presentation is both sustainability and circular economy. So switching to the second concept then, very briefly, circular economy has as many definitions, quite lengthy, and complex in some cases. But in my words, it really is use as little resources as possible, for as much and by as many as possible. That is during the use phase, whichever product or facility, whatever we're dealing with, really make advantage of it while it's in the use phase, and use it for as long as possible. But again, we see this translating into the nuclear industry, that we see lifetime extension, refurbishing projects, sometimes even restarting a facility that has been permanently shut down is happening and being discussed more and more. That's a circular economy. But the topic, of course, of this presentation is decommissioning. And decommissioning in a circular economy really corresponds to closing the resources. But if you are to have a true circular economy, you need to look at the whole life cycle of the material or the component or product, whatever it is, meaning before it even starts, during the use phase, and after. But from a circular economy perspective, again, it is relevant in decommissioning, but it's just part of the story. Decommissioning or a circular economy cannot be achieved by one organization alone. Now, and since all the way back from design and manufacturing, using and then taken back, whether it's your little washing machine or car or mobile phone, whatever the product is, it then goes back, is either taken apart, remanufactured, sold again, or you, of course, recycled. That can be part of a circular economy, but it's really the last resort.
Christina, I'm going to jump in here and just let you know you have about 2 minutes left.
2 minutes? Oh, I didn't realize that. Okay, sorry. I thought must have misunderstood the timing. Okay. The current decommissioning practices that are consistent with circularity, because parts of it is done, repurposing of the whole or part of the site. This is an example from a research reactor in Stockholm that is now an asset. It's been fully cleaned and cleared, but used for, in this case, music recording. Many times it's used while you can use parts of the site for something while you await dismantling and taking the facility apart, reusing systems and components, of course, but whether it's on the same site or another site. Clearance and recycling of non-metals and other materials is definitely being done. Using demolished concrete as fill materials on the site or elsewhere as, again, kind of a last resort, but of course it's better than a disposal, sending to disposal. And simple things, reduction of power and water consumption is also consistent with circularity, of course. Reprocessing of spent fuel, I put a question mark on, because I think it depends on really whether the country has, for example, a reprocessing facility. It's just one component. If we really are to have circularity of a nuclear site, I believe we need a model that can do this and look at it from a site perspective, where you look at all the flows of material to and from the site, and also it can go from operation to I refer to transformation, really decommissioning, and also building up to a future use, whatever that use may be. To conclude, again, some of the current practice definitely are consistent with sustainability and circularity in the nuclear industry, but I believe a lot more can be done. And how to do that is to think more systematically and again, really approach the parts of the system as a potential asset. Use holistic thinking. Local context is key. A sustainable decommissioning approach, if done appropriately, can, in my opinion, and using resilience thinking, reduce uncertainties, the timelines until you get a new future use, the waste volumes and costs. And now is the window of opportunity to revisit and change the norm of how to decommission these large facilities that really are assets for other types of uses, given that both about the same time. There are many reactors that have or will be reaching the end of operation and require decommission. And as also Horst mentioned, the small modular reactor and other new reactors that are anticipated to be built in the coming days, they should be designed not only for decommissioning, but for a circular economy. Thank you so much.
Thank you, Christine. I think that you made an excellent presentation. In the interest of time, I will not ask you one of the questions that I had, but just to emphasize the importance of your messages that, for example, regulations that were made thinking about safety but not on sustainability. I would say that regulations that were made take into account a linear economy, not a circular economy. You also mentioned, and the speakers before you, the holistic thinking, which I believe is a very important, and also the changing mindset. And I guess that the commissioning community is very much focused on installation on the installations above ground, and not too much thought is given to the site itself. And as I say, the interest at the end of the day is that you remove the installation, the facility out of regulatory control, ideally for unrestricted use, but other uses should be thought about and bring the circularity thinking to decommissioning. So no questions from my side. In the chat, many interesting resources. I ask people to take a look. So I will hand over to Becca.
Thank you. So we will go ahead and introduce our final speaker for today, and then hopefully we'll have some more time for questions following Elaine's talk. So Elaine Percara will be our next speaker. Elaine has 31 years experience in environmental remediation, design, oversight, maintenance, and operations. She is the chief engineer for the U.S. Department of Energy Hanford Field Office. Elaine holds a bachelor's degree in mechanical engineering and a master's degree in industrial engineering. She is a registered professional engineer in Washington State and a leadership in energy and environmental design legacy accredited professional. Elaine has broad expertise in nuclear facility design, operations and maintenance, and specialized expertise in nuclear facility confinement ventilation, design, operations, and oversight. Elaine, the floor is yours.
Can anybody see my slides?
Yes, we can.
Great, wonderful. Okay, well, we don't have much time left, so I'm going to jump through these just as fast as I can. I am going to talk today about a couple of initiatives that Hanford is considering that I think are really great examples of the principles shared by Paul and Sarah and Christina. So it ought to be a good way to wrap up today's session. But first, you'll have to bear with me. I have to tell you a little bit about our site and our site history to help you understand some of the things we're doing next. So many folks have described us as the sequel to Oppenheimer. Hanford is a Manhattan Project secret site, a World War II era site. And we produce 2/3 of the country's plutonium stockpile here at the Hanford site. We had 9 operating reactors along the Columbia River, the largest outflow of water to the Pacific Ocean, here on our 500 square mile site. And then we had 5 large chemical processing facilities known as canyon buildings in the central plateau of the site, located 7 miles apart. And that's where we separated the plutonium from the spent fuel rods. This site was in plutonium production until 1989, when we became the country's largest and maybe the world's largest nuclear cleanup project. We've been exclusively a cleanup project since 1989, and we probably have another 40 to 60 years to go. So at each of those large canyon chemical processing facilities, co-located with those were several tank farms to receive the liquid wastes from the process and the effluents from the process, and the solid wastes from the processes. These tanks they range between 35,000 and 1 million gallons in capacity. And we built them from 1943 until the late 1980s. We built single shell tanks until 1965. Those are the ones shown in dark green here. And then in 1968 began building double shell tanks. So those are the ones in the lime green color. And here's where they're located on our site, and here's where we're located in Washington. You see these sites are fairly remote. They're 7 miles from each other. And those tanks hold a whole lot of waste today, about 56 million gallons of radioactive waste. We've retrieved 22 of the tanks at present. And we also completed interim stabilization where we pumped all the pumpable liquids from the single shell tanks into the double shell tanks. So the majority of the liquid waste is now in the double shell tanks, but the single shell tanks still need to have the solids and salt cake retrieved from them. So the first step in our remediation process for that very challenging tank waste mission is tank retrieval. And you see the photos here. This is an extended reach sluicing system, an ERSS, being inserted into the riser of tank A101, which is the most recent tank to begin retrieval. And then you see pictures from our last tank to be retrieved. So this is sort of before retrieval. You see the extended reach sluicer here. Here's the ERSS in work on the side of the tank as retrieval is happening. And this is an in-process picture too. So the sluicer essentially dissolves that salt cake and makes a liquid waste form that we can then pump to the surface, put in a double shell tank, and forward to further treatment. So what's next after retrieval? We have an evaporator. It's been on site since 1976 in operation. That reduces the water volume. As you can imagine, the retrieval creates a lot of extra water, and we have limited tank space. And then we pre-treat the liquid fraction of the waste to make a low-level waste form. So we filter out the solids, and we run it through a series of ion exchange columns to remove the cesium-137 and strontium-90, which make up about 95% of the radionuclides. Here's the TISCR system where we do that first pre-treatment step. So you see the filter units here. Whoops, went too fast. Filter units here, and then a lead, lag, and polish ion exchange column. You see an overhead here with the TISCR unit, which is a modular treatment system sitting in adjacent to the AP tank farm. And today we've got about, actually this slide is already outdated since I cleared it a month ago. We've got about 800,000 gallons treated and waiting for solidification. And then this is the spent crystal and silicotitanate resin sitting in the columns on the pad adjacent to the TISCR unit. So what's next after pre-treatment? Stabilization to create a solid waste form for permanent disposal. Our baseline approach has been vitrification, which is mixing with glass formers, heating to 2100 degrees Fahrenheit in a furnace, a melter, and creating a glass waste form. We do that at the Waste Treatment and Immobilization Plant, WTP for short. And WTP is in construction with the low activity waste vitrification facility in commissioning, and the high level waste facility in construction and expected to be online in the mid-2030s. The low-level waste will be disposed on-site, and the high-level waste will stay on-site awaiting an off-site high-level waste national repository that we do not have identified today. There's this other fraction of waste. So when the HLW facility comes online, we have essentially twice the volume of low activity waste to treat, a lot more than the low activity waste facility at WTP can handle. So we started discussions quite a while ago about what to do with this waste. Baseline approach was to build a second low activity waste vitrification facility. And I'm going to talk a little bit about the alternatives, one of which is suspension and grout. We're working our way through our test bed initiative now to test that approach. And then we have a potential West Area risk mitigation project to follow, depending on the NEPA, which is in work now. Checking time. Here's the WTP site. So once upon a time, we had the pretreatment facility. It's still in construction. Well, it's paused construction now because we have the TSCR unit, which is in itself a sustainable remediation example, performs the same activities with the exception of effluent treatment. So we have an effluent management facility here. The intent of pretreat was to split the waste stream into high-level waste and low-activity waste by filtering and performing ion exchange, as well as the effluent capabilities. We have the high-level waste vitrification plant here on the left, and the low-activity waste vitrification plant here on the bottom right, and then a lab facility. As you can imagine, there are a lot of people that have a lot of passion about our mission and care about our mission. This chart here on the left describes some of that. So as we were considering what to do with the supplemental fraction of low activity waste, how to bring all these folks together, how to share the different alternatives in a science-based public way was a challenge. And lucky for us, Congress mandated a National Academy of Sciences, Engineering, and Medicine review, NAS for short. That lasted 7 years. There were actually 2 different reviews, but about 7 years. It started in 2017 and just wrapped up late last year. These were open public sessions to review technical information and results. There was an independent scientific analysis performed by several national labs, including some of the folks on this call. And then their results and evidence was shared openly. All the regulators, stakeholders, tribal governments that really are passionate about our site were there and able to provide input and presentations. So it was really it was a great outcome. The conclusion was really broad acceptance for an alternative treatment path for low-level waste. And to help accelerate the cleanup mission, not only is it less expensive, more efficient, faster to get those tanks retrieved, but it offers an opportunity for up to 70% of the long-lived radionuclides that are resident in that low-level waste fraction to be disposed of at commercial disposal facilities out of state that do not have a path to potable water, versus disposing those here on the Hanford site adjacent to the Columbia River. So that was really, that was an aha moment and a bit of a win-win for all those involved. And so part of this review, during part of this review, we took a whole flow sheet look at sustainable remediation. There were calculations performed, and they looked at really the 3 different alternatives that were considered. I'm going to feature 2 of them here. And they looked at it from a whole flow sheet perspective, not only the final waste form and the cost, which were the 2 factors that had been considered before to form the baseline approach, but also all of the inputs, the energy, clean water, fuel, chemicals, waste formers, the outputs, the emissions, the effluents, the primary and secondary wastes, not just the primary waste. And then the worker hazards, chemical and physical hazards, as well as radionuclide hazards. And then we pulled those numbers together. We pulled them from actual facility flow sheets. So the WTP, as it was finishing construction and being started up, as well as Savannah River's Saltstone facility for grout. And then we converted those to the same scale, to 1 million gallons of feed basis, so that you had an apples to apples comparison. And just for reference, there's about 100 million gallons of low-level feed in our entire tank waste mission. So here's kind of the outcome. You see the big picture here of a vitrification mission. And I won't dwell on these too much because we don't have a lot of time, but here's the comparison. So per 1 million gallons of feed, Vitrification, here's the inputs in blue. So 2 million gallons of water, 3 million gallons of diesel, et cetera, et cetera. A lot of trucks. The electrical demand is very high compared to a much smaller electrical demand for grout. And then the emissions, and here's a key one, the primary waste form looks like it's a much lower volume, but then you start to look at all these secondary wastes, the effluent that has to be treated through another 12 steps of treatment and disposed. So when you add up all of this, it just became clear that grout was a much better option for us, also way less worker hazards. So the testbed initiative, which is being started now, we've actually removed 2,000 gallons of waste through this in-tank pretreatment system. It contains the same filtration and ion exchange steps, just in a smaller package because it's a smaller volume. We've removed that waste from tank SY101. It's awaiting sampling, and then it will be grouted and shipped for permanent disposal out of state at a commercial disposal facility like all of the other low-level waste in the DOE complex. So this test just really demonstrates that this is a feasible alternative. And the next step, so once TBI has gone well, and in parallel with the National Academy of Sciences study that was done, DOE was in holistic negotiations with our regulators, EPA and the Washington Department of Ecology, and this agreement was formed. So this is the holistic agreement, which is not final. It's in public, finished public comment. So the public comments are now being addressed. So assuming this was the final agreement, these would be the things that would be pursued. Key one here is this last bullet, retrieving waste from 22 tanks in Hanford's 200 West area by 2040. That's a lot sooner than we can get to them if we have to build another vitrification facility or with a single path of vitrification alone, including grouting the low activity waste portion of the waste for offsite disposal. So talking about the impact just from a carbon emissions perspective. So that secondary vitrification plant was this medium blue wedge right here. Whoa. And so here in green is what happens. That's about a 60,000 metric tons of CO2 per year decrease in our carbon emissions. So this is a really significant net zero initiative, as well as it saves $9 billion in life cycle costs and allows us to complete the SST, the single shell tank retrievals, 9 years sooner per the National Academy of Sciences and the National Lab Review that was embedded within it. So we looked at this green chart. We have these goals for net zero per Executive Order 14057. And you notice we're still going up. We're not going down yet because our mission was much different back in 2008, when they wanted us to take the baseline. We hadn't started the tank waste mission, which is the most challenging and energy intensive portion of our mission. But we said, what else can we do? Is there anything else we can do to reduce these numbers more? So we took a whole flow sheet look at the WTP that forms all the green here. This is the low activity waste mission. This is the high level waste mission. And we looked at what we can do. And WTP is now at 60% design on a electric steam plant that will replace the diesel fired steam plants that are there today. We need steam in the process for heating, but also for evaporation of the waste. So this was really what we could do to reduce carbon emissions further. That's a 43,000 metric tons CO2 per year reduction. It won a DOE grant last year, and we're pretty proud of that. Here's what an electro boiler looks like. They're not only much more efficient than their diesel equivalents, but you don't need to treat the water ahead of time, and they have a much better turn down ratio. So they give us a lot more operational flexibility. And here's what it does to the costs. So these are our energy costs, total in yellow, and then fuel cost in gray, electricity in orange, and then Washington has a carbon tax. So that's in blue here, the Washington Climate Commitment Act. So total cost in the 2050s, $300 million without electrifying the boilers. And in the 2050s, about 100 million. So 200 million savings with that one project, electrifying the boilers. So this is significant. We'd like to get it down further. We have some other projects in mind because this is still a significant amount of money, but 200 million. So you can see it's not only the right thing to do from a sustainability perspective, but certainly it helps us in terms of mission efficiency as well. So quickly, I have just a couple more minutes. Here's some advice for sites looking to do sustainable and resilient remediation or electrification projects. Definitely engage regulators and the community in remediation planning and evaluation of alternatives. National Academy of Sciences has a nice structured way to do that. There are lots of other ways to do that too. Frequently, there's a win-win for all parties. And I think that process for us really brought that to light. And then a whole flow sheet, cradle to grave flow sheet approach to the carbon emissions, and not just carbon emissions, but any alternative you have for how you're going to remediate your waste. I think that's where we identified some of our biggest wins. And those commercial building standards, lead and guiding principles, they're really great for commercial buildings. But when you've got an industrial process, a unique first of a kind mission like we do, it's hard to apply those, and sometimes they can lead you to overlook some of the biggest emissions and cost savings. And then carefully consider future energy strategy. So electrification, there's a lot of reasons to electrify. There's a couple of reasons that could cost you some money. Depending on your power contract, you might have contract high water marks, above which you pay higher power rates. You might have new large single load stipulations, where if your power increases too much in 1 year, you pay a premium as well. Some providers limit the amount of renewable generation you add. I know that's the case for us with BPA. So we sacrifice our entitlement to wholesale power for every 3 megawatts of renewable generation that we bring online. And not electrifying can also come with some pretty significant penalties if you're in a state or a region where you've got carbon taxes. So those are things to think about just in terms of before you go forward, make sure you factored that all in. Are there any questions?
Thank you, Elaine. That was great, and we appreciate. I know it was getting squishy with time. I think all the speakers just had such good content. We knew it was going to be difficult, but that was a great overview. If anyone does have any questions that they want to follow up with, I'm sure we can do that after the presentation, but we are pretty much at time, so I'll hand over to Horst if you have any closing remarks. But otherwise, I think we are, or sorry, to Karen for closing remarks, but I think otherwise we're right about time.
Well, we are, but Horst, I want to give you a chance if you have anything you want to say.
No, I think that is a wonderful presentation, and when we were discussing this, I was pretty much in love with the content because it gives us a very concrete examples of how these things come together. My only question here, if you allow me to stand in 30 seconds to Elaine, when there was a decision for grouting, there were any issues about safety in that process? Any kind of perception that safety could be relaxed or made flexible?
I think in this case, it actually turned out that the grout process is much safer then the vitrification process will make both safe. We have controls to do that. But the point is, you're not heating the waste to 2100 degrees Fahrenheit. When you do that, the chemicals in the waste, a lot of them are volatile. So they boil off into the off-gas stream, and you have these high chemical hazards that you have to mitigate with off-gas treatment and controls. So a lot of scrubbers, a lot of other off-gas treatment, and a lot of places in the facility where you really have to be careful and monitor for leaks and that sort of thing. So with a grout process, it's a cold process, so you aren't adding temperature, besides just heat of standard concrete temperatures, but you're not bringing the waste to that high of a temperature, so you're really not creating any new hazards. So when we looked at it, I think it was 12 versus 38 worker hazards, and the 12 were at the medium level per our safety evaluation, and the 38 were high. So big difference. So we did definitely consider worker safety, nuclear safety. With the low level waste, there's just not a lot of radiation left in it after pretreatment. So it's really a chemical problem at this point in the flow sheet.
Excellent. Thanks, Karen, for the opportunity. Reinforce that sustainability and safety are fully compatible. Great discussion. Thank you. Back to you, Karen.
Yeah, so I want to thank everyone today, our presenters. You did an excellent job, really good information shared. We had a great attendance for the seminar, showing that the topic's really relevant to people. And also thank you, Becca and Horst, for facilitating. We do appreciate if you see a survey pop up when you exit, please fill it in. We thank you all for joining us, and stay tuned. We'll share more information about future events, and mark your calendars for November 4th through 6th of 2025 for our Global Summit. All right. Thank you, everybody. Bye-bye.
Thank you all.
Bye-bye.